My name is Richard Ferrer, and I can say I am cloud hired.
That yes, come and join and get cloud hired. I'm cloud hired.
I'm cloud hired.
I'm cloud hired.
Hey, Go Cloud Architect family. I'm cloud hired.
I'm cloud hired, guys.
So I'll just say I'm cloud hired.
I'm cloud hired.
I'm cloud hired thanks to Go Cloud Architects.
It worked for me, and now I'm cloud hired. Because of Google Architect program, I am cloud hired. See!
I am cloud hired. Thank you, Mike and the GlowCloud team.
Welcome, everyone. This is Mike Gibbs, and today we're here to have some fun. We're doing some cloud security training, and we're going to be talking about designing zero trust cloud security architecture. So welcome, everyone. If you know me, you know I've spent a lot of time in security, and you know I'm very passionate about it. So I love discussing security, and that's what we're going to be doing today. Before we begin, tell me where you're from. I'm over here in Port St. Lucie, Florida. It is nice and warm outside. My cat's actually outside having a good time. She doesn't like it when it's too cold, but that's where I'm at. Let us know where you're from. I see a Philadelphia. My wife's over there right now, actually. So I see some North Carolina, some Georgia. I love this. UK. I'm sure soon we'll have people in a lot more places, and I love that. So wonderful. So before we begin, and we're going to have a lot of fun with some security architecture fundamentals, I wanted to tell you about two things that we have going for you that are free. If you desire to become a security architect or want to learn what an architect actually does and the skills that the architect has, because a security architect is completely different than a security engineer, for example, and you're looking for your first architect job, I host a webinar generally twice per week for architect roles, but tomorrow we have one geared towards security architects. And we'll talk about what we do as architects, the skills you need as an architect, how to transition careers, how to be able to get employers to come to you so you're not applying and get auto-rejected, all those things. And it's on Zoom, so you can ask me any career question you want about anything in architecture careers, and we'll do what we can on these free architecture webinars to help you. So there is that. We also have a mailing list, and if anybody wants to sign up for the mailing list, Chris from my team is going to drop the link to that. At the end of this 3-hour Cloud Security Architectures Fundamentals course, I will make sure that my team sends out an email with some of our free cybersecurity training, like the CCSP training, for example, or the CISM training to assist you in your security career. So that was all about that. Now let's talk about security architecture. And I want to know you're awake, you're alert, you're oriented. If you're here, give me a hashtag cloud security architecture or security architecture in the chat box so I know you're there. So what we'll be doing here is, in the beginning of today's discussion, I'm going to really make sure that you understand why cloud security is different than traditional security. I'm going to talk about how attacks actually occur in the cloud. I'm going to talk about how the cloud is actually architected, where the cloud would get hacked differently than your data centers. Because when you understand that, you'll be in a position to know how to secure it. And because the cloud offers so many unique challenges, it almost forces us to use a zero trust architecture. So today we're going to talk about zero trust architecture in the context of cloud security. So we should have some fun here. At least for me, I love this kind of stuff. It's been what I've done for the last 25 years. I came from healthcare 25 years before that, but I love architecture. So let's talk about it. So if we're going to talk about cloud security, and if we need to talk about why we need to do different things here, and what are the new attack vectors on the cloud, I want everybody to understand exactly how clouds are architected, exactly what goes into a cloud, where those inherent risks are, and how a hacker would actually break in. So when you know that, we're going to have fun. So that's what we're going to do first. First thing I'm going to do right now is I'm going to draw a cloud provider and I'm going to draw an internal organization because there's a couple of things that I needed to see immediately. And when you see that, it'll make it much easier for you to understand how, when you do a cloud migration, for example, the security changes you need to make. So, if you know me, I love something that I can whiteboard on in real time. So if we were to build right now, I'm going to show you two different things. First thing we're going to do is we're going to build something that will look like a cloud provider, or it will look like an enterprise. If we go into any enterprise, they're either going to be using a cloud provider, which is, I'll show you what that looks like in a minute, or they're going to be having their own data center. In most cases, they'll have their own data center, even if they still use cloud. But if we really think what goes into building a system that operates 24 hours a day, 7 days a week, it's going to take a few things. So generally speaking, when we're dealing with a cloud provider or a data center, we need power. So whenever possible, if we're building a data center, we typically try to get power from two different companies if we can. Now, two different companies, multiple power transformers, you have to worry about this. Now, when we go out, we have a data center, we typically need two kinds of connectivity. We typically need connectivity to the internet, and that's the public internet. And that means we'll have more than one internet service provider. The internet is where you would go to go buy cat food, for example, or whatever you want. And then they will also have links that are going to be going to other data centers or other offices that they have. And that's going to be private lines. They're going to, in many cases, MPLS type environments. So that's going to be intranet links. And that's what people like me that spend a lot of time in network architectures, we're designing these intranet networks. So if you look at a building like this, maybe I need to bring some of the stuff over a little bit more to make this a little clearer. That stuff's all going outside the building. One thing that happens when you deal with computers, routers, switches, firewalls, do you know what they hate? They hate heat, which means in an environment like this, you're going to have a whole lot of air conditioners. Now, because even if we have two power companies, it's possible that there's a hurricane or something big that could take out both power companies. We're going to have two different things going on. All these organizations typically have generators. And you can't have just one generator. You're obviously going to need multiple generators. Because anytime we have one, it's a single point of failure. And what can go wrong will go wrong. And these buildings are also going to have a battery backup, typically in the form of an uninterruptible power supply. And here's the way this works. If the power goes out, the battery temporarily provides power to it. And then, the system senses that the system's on battery and then starts the generators. So that way the systems don't get shut down and rebooted. Now, inside this environment, there's a reason I'm showing you this. There's going to be a network. And this network, realistically speaking, is going to be routers and switches. Well, they're going to have a lot of them in most cases. And what's going to plug into routers and switches in today's world in any company or a cloud provider is going to be servers. So these are going to be physical servers. And they'll have racks and racks and racks of these things being plugged into the network. We will have storage networks, such as block storage, for example, and object storage. And these are basically boxes full of hard drives. And that too will be plugged into the network. And for the most part, everything's going to run on this. Now, if we have a virtual machine, it'll be running on one of these servers. If we have a function as a service, the serverless functions, it's going to ultimately run on one of these servers inside of the server farm. So this, by the way, is what you see in a single customer. So what I just showed you is a private cloud. Now, I didn't show you one element of the private cloud, which I'm going to show you next. Then we're going to do the public cloud provider, and then I'm going to draw out the real issues between the two, and then we're going to talk about the hacks, and then we're going to secure it. So we're going to have some fun here, but here's what I want you to see. Right now, this just looks like a bunch of servers and storage and routers and switches. Now there's internet connections, which means there's firewalls to things and routers attached to this, but this is basically what you see. Every data center in today's world, and for as long as I can remember, has a control plane. If you're running a Nutanix cloud, it's got a control plane. If you're using a VMware cloud, it's got a control plane. If you're using an OpenStack cloud, it's got a control plane. And what happens in this control plane is the engineer, either with an infrastructure as code script or a command line or click something on a management console, says, create a virtual machine, or I need this virtual machine. Now, what happens, the control plane says, here is a virtual machine. I can fit it on this server. This server has this capacity, what have you. And then the virtual machine's placed here, and the control plane says, I have a little less capacity. Then all of a sudden, we have some an application. We have, say a function as a service we run it. The control plane says, oh, okay, here's a pooled set of servers. I can run that function as a service, like a Azure function or AWS has a Lambda function, same kind of concept. And that's the way all this stuff works. Now, inside of our data center, I've got a virtual machine that needs access to block storage. The control plane provisions it outside of the storage. So this is what a private cloud looks like, or customer data. And that way I can have one DevOps engineer launch 10,000 servers on my pool of servers, just like I could in any cloud, scale in, scale out. That's a private cloud. And most enterprises have this. Now, all right, Mike, so what's a public cloud? Well, guess what? It's the same thing. In the architecture of each data center, they're all the same. Now, what's different about the public cloud, and there is something, is that it's much bigger. And that means in many cases, they have more servers, they have more routers, they have more switches. Now, when you get to big scale, a lot more things can go wrong. So understand that. But where is the other difference? In the organization's own company, inside of this data center, it's only their own company, and there's nobody else's data. Now, all of a sudden, we're going to turn this into a public cloud provider, and this is the cloud provider's control plane instead, like the AWS management console, for example. And with that cloud provider, you've got tens of thousands, maybe 100,000 all information stored on the same storage and the same servers. Your own data center, it's yourself and a cloud provider, it could be 10,000. And guess what? If the FBI or some other federal agency decides they need to take the hard drives that a single customer is on, your data could be with it, including the secret formula of your multi-billion-dollar new pharmaceutical at the drug company. So that changes something to think about. Now, there's one other thing that really, really matters. And when I talk about how to secure it later, we'll come back to this. So that is, and actually, before I do that, I want you to get a little more knowledge of the cloud provider itself, because I think this will help you. So we have this data center. I showed you to it before. So what is a cloud provider really going to look like? Well, here's what they're going to do. They're going to have a whole bunch of data centers. And all these data centers will be relatively close together, and they'll all be connected by high-speed fiber optic connections. And when I say high speed, we're talking multiple 400 gigabit per second connections, like a lot of them, big high-speed connections. And all these environments are going to look like this. So let's put a couple of them here, and I'll show you why. So what we have here is we have an area, a part of the world where the cloud provider has several data centers. They often call these data centers availability zones, and they often call this large geographic area a region. So this would be a region. Oh, I don't want to do that. This would be a region. This would be a region. And this would be a region. And then what will happen is these regions all run their own networking internally. And then they're typically connected to each other with BGP, which gives them some control of routing and tuning along the way. And then I think when we talk about just, this may help you understand things from an availability perspective as well. All this stuff is all connected, and there's a control plane here. So that means if you are a user and you're in a Japan region, for example, of a cloud provider, you can hit that control plane and then do something in an African region of that cloud provider, and then also do something in a US. So when we talk later about control plane and control plane attacks, realize if that control plane's messed up, the whole cloud could be messed up. But let's get into the real difference. And the real difference is the way data center security on private cloud is versus public cloud. So in a normal environment, this is internal. Here we have the internet over here. And this changes the game. And then we're going to get into the kind of fun attacks that hackers could do. So over here, we've got our firewall. So in this particular environment, if we have web servers, for example, they're in what's called the demilitarized zone, and they are literally outside our internal systems. And that means that we can control what goes through the firewall to reach the web, but the web can't go back into our internal systems because it is outside the firewall. So, and if you're unfamiliar with firewalls, and I'll just briefly show you the way the firewalls work, is my internal users can go through the firewall. The firewall will see that an internal user sent it. It'll allow it out to the internet, and then it'll allow the user internet's traffic back in. But if the traffic is not initiated from the inside going out, what'll happen is the firewall will just block it. But the firewall will have a rule that says you're allowed to access TCP port 443 in this particular subnet. So that's traditional security. Okay, well, what do we often have in the cloud? If the cloud is not designed right, and that's why we're going to be talking about this later, but you'll see this all the time. You will see someone that has an internet connected subnet, or worse, a bastion host. And they'll have the internet connected subnet. And then inside over here, they will have private data and private subnets. And then they'll have another private subnet, and then they'll have another private subnet. So if you're actually letting traffic in, which in many cases what we do in cloud computing, into this castle, here the traffic couldn't get into the castle in the first place, and now you're letting it in the castle. If we don't do everything we can to make sure there's no traffic that can go from here to here or here to here or anything like that, we're going to have a problem. So those are the things that are going to change everything. The internal versus the external, how many people's systems are going to be there. So that's your first thing that I want you to think about. So let's talk about how cloud breaches actually occur. And then I think it'll make some of this much, much, much more obvious to you. So the first one, realistically speaking, is going to be a misconfiguration. So I want you to think about this. If I am in a traditional environment and my storage is behind the file, let's do this. Let's get rid of the fill here so I can show you. If I am in my private environment and over here I've got a file server or object storage, whatever, and I've got this employee and let's say Dimitri, Dimitri over here saves a file and he sets the permissions incorrectly on the file server. Well, no one in the outside world can reach it. Now, internal people might be able to, or internal people might be able to do something, but outside nobody will reach it because that file server is not reachable from the internet. It's still not a good thing. But now, realistically speaking, we're using a cloud provider. And now, in this particular case, we have Michalis. And Michalis over here, I'll just call him, decides that when he's going to store a file, he accidentally sets that permission to public. Well, the problem is the object storage in the cloud provider is connected to the internet. So as soon as Michalis makes a mistake, that file is available on the internet. Here, somebody else inside the company might see it. Here, somebody outside the world can see it. So that's kind of a big deal when we're dealing with cloud issues, because once it's on the internet, anyone can get it. And in many cases, if it's set improperly, there's not even any authentication that's requested to be downloaded. So if we actually look at one of the biggest cloud breaches, it's actually misconfigured object storage buckets. One of the biggest breach patterns inside of security. So the next thing that can go on is what's called an identity compromise. And this can happen in absolutely any kind of environment. So a hacker goes and gets the identity of someone that's got real power inside of your systems. So let's, for example, say that I've got a senior DevOps engineer. And I can take that senior DevOps engineer's account, who can create new cloud workloads. They can, if they wanted, because that DevOps engineer has the ability to create a workload, run a workload, remove systems, start systems, maybe create an IAM policy or something like that. So in this particular case, somebody does a phishing scam, somehow finds the strong DevOps engineer's information. Now they've got all kinds of things that get done, and we see it. They're creating new cloud accounts. They're deploying malicious workloads. They're accessing sensitive information. They're deleting logs, hiding activities. So the result is the attacker basically has full access to the account. So that's obviously going to be a problem. Now, the next one that we see constantly is API exposure. So I'll show you what I mean by that, because we're going to talk about how to fix this later. So let's say I have an API, and I'll show you what they would typically be used for. So we've got an external vendor, an external provider who's supposed to be using the API. They feed information in and out through an API, kind of like when you basically write or the DevOps engineer or a cloud engineer writes a Terraform script and then deploys it. So they hit that API, and that API is supposed to take some action or do something on a backend system. And this is great. It's supposed to do this. If it's done correctly, this is what's supposed to happen, all within the scheme of things. But what ultimately happens is not everyone, and we're going to talk about it, and by not everyone, I mean a lot of people, and a lot of people don't know how to protect this API. And if this API is not protected, then realistically speaking, we can have a hacker over here attack the API. And what I mean by that is, let's say this API can handle 10,000 transactions per second. The hacker can send 50,000 transactions per second and take it down. If the hacker, for example, if the API doesn't require a lot of authentication along the way, people can pull that API and actually get information out of there. Maybe pull customer data out of there. So we'll talk about how we secure that, how we protect that, because a lot of work needs to be done there. But it's a common attack pattern. Now, this is something that happens all the time. And I see it in the cloud, and it usually comes when people don't understand networking and they find networking complex and they find BGP complex. Because that, it is complex, but I'll show you what I mean. I initially showed you the internal versus the external environments that exist. But let's imagine now, and I've seen this, and you'll see it if you're an architect, you'll be fixing these in other people's environments. So there are people that literally will put their internet workload over here, their public workloads. And then inside of here, they'll have a set of HR systems. They'll have finance systems in here. They'll have industrial control systems that are inside of here. They will have sales systems inside of here. And by the time you're done, this environment hosts so many people and so many systems. So somebody gets in from the public internet and they hop and they hop and they hop. This is a nightmare. Now, the reason I say it's a networking thing, and we'll talk more about how to do that later, is if HR never needed to speak to the systems, never needed to speak to sales systems, we could have put them in their own VPC. And then we could do the same thing for the sales systems. And if we don't do any routing between them, they can't even reach each other. So there's going to be a lot of ways that we're going to talk about how do we protect these things. But that's the nightmare of having a VPC where or a virtual data center where you're allowed to basically have your stuff and the internet stuff at the same time. Maybe not a great idea. Maybe have an internet VPC, which we'll talk about later, and internal ones that are there to protect things. So that is a no-no in any environment. Now, another thing is you'll run into organizations that have very weak access controls. People switch from job 1 to job 2. The permissions and the capabilities they have inside of the systems don't change. So what do I mean by that? So I've got a systems administrator that needs to access a lot of systems. 5 years later, they're a manager. They don't touch any of these systems anymore. Now they touch HR systems and finance systems and incentive pay systems and vacation systems and all these other systems. That manager no longer needs and should have that access removed to being able to do the systems. What happens a lot of time is they never remove it. So now that person keeps their systems administrator, and then they have that. A year later, they're in the marketing department and they still keep these things. And then somebody compromises that account. So these things get there. But there are times where we see wacky things like we have someone that can create other policies. And sometimes that's needed for the job, and sometimes it's not. So let's say in this case it is. I'll show you what I mean. Let's say we have a developer, and he's a good developer, she's a good developer, what have you. That developer, in the course of their job, might need to create an IAM policy for a system connecting to another system. Now, that policy might mean they can do that. So here we have a great software developer. It's Apostolis. Sorry, my family's from Greece. I typically think in terms of Greek names first. So we have Apostolis, and he is a great developer. And he has the ability to create resources, modify security policies, access sensitive storage, delete logs. And somewhere along the way, Apostoli stops for lunch. He gets some souvlaki. He gets some beer. He puts his system down. Somebody finds his username and password. Now, look at what that hacker can do with Apostolis. Create accounts, delete accounts, create anything they want. So that's kind of one of these things that's there. Now, where else can it get worse? So, credential theft. We've been talking about this a little bit, but let's say a hacker steals somebody's AWS access keys from a developer's laptop. Inside that, they discover GitHub repositories, local configuration files, CI/CD pipelines. So, and then they have those credentials. And then they can deploy a cryptocurrency mining workload on GPU-enabled servers, and things can get real expensive real fast. So that's realistically what we're talking about. And the last one that we're talking about is that control plane manipulation. Well, actually, I probably should talk about supply chain too. But let's talk about manipulating the control plane. If we can manipulate this, either to the cloud provider or to your systems, either way, we can get what we want. So if we can hit the cloud provider's control plane as a hacker, we could cause all their systems to be doing whatever we wanted them to. Could be deleting any system we wanted anywhere. Could be doing just about anything. So obviously the cloud provider's control plane is an extremely high value target, and they've put a lot of money into security for that. But what about your own control plane? So, and this is actually another risk difference between cloud security and traditional data center security. If this is your data center, it's your own company, you are responsible for all of this, and you are in 100% control of this. If you are in a cloud provider, you have your virtual data center, and you are in control of that, and that's where I'm going to get to next. But the cloud provider can still be hacked, and it does happen. And when they're hacked, who knows? You know, Azure was honest enough and disclosed what happened when DynamoDB was hacked and how customers' information was shared. Maybe not everybody's that ethical, but you know, think about that as we talk about it. But so we've got our organization, and our organization has their own, whatever you want to call it, control plane. So this is now your organization that you're thinking of, and you log into your account. Somebody gets into your account somehow, and when they have access to that account, they can do anything they want. So I know some of these attacks start to look and feel like they're the same, but they have access to your control plane. Oh, they're changing your routing, blocking one thing from talking to another. They might disable monitoring that you may have had set up. They could create new users. They could remove firewalls. They can remove access lists. They can copy data. So many things can come here. So how do we protect this? So actually, let's do this. Give me a hashtag security architecture so that I know you're listening. And after that, I'll see if anybody has any questions. If you have so, drop some questions in the chat box, because we're going to talk about how to secure it next. Just give everybody a chance to see if you do. While we wait, inside of the description of this video, we actually have some free guides that will be hopefully very helpful to you in your architecture career. Kind of talks about what things that we do, skills that you should have, and they're free. You can just sign up for them. We've got guides on how to win the interview to make you more successful on your interview. It's free, so it's in the description of this video. Sign up. And tomorrow, again, we're going to have an architecture webinar. So in that webinar, we're going to talk about what we do as security architects. We're going to talk about the right skills to have as security architects, what hiring managers are looking for, what hiring managers actually want, the kind of things that belong in your security architect portfolio, all of it. So maybe join us tomorrow. I haven't seen any questions come in. And maybe that means I'm just explaining it so well, or it means people are shy. Don't be shy. So just want to do everything we can to help you. Give it a couple more seconds. And if not, I'm actually going to get into the things we can do to actually do those. All right. Well, hopefully everybody's with me so far. So now let's talk about what we can do and how we can do this. So remember, in our data center, things were a lot different. And I'll show you what I mean. Go back to it. This is our data center. We own 100% of this. Typically speaking, anything outside the internet is outside of this environment. It's deeply protected. Anything we have inside of here, we either have Microsoft Active Directory or something like that. We already have access lists, controls, and firewalls inside of here. It's all our stuff. And for the most part, we are a much lower target here. But in order to be able to use these systems, you either had to be in the same building or you had to be in a building for the most part. Let's say the building was over here and you had a wire between, the New York office and this data center that it was sitting there in Reston, Virginia. There was basically a pseudo, it was either a MPLS pseudo wire, it was a private line, that kind of thing, or potentially an IPsec tunnel, but everything was private. Realistically speaking, you could trust this server to this server because you owned them all and they were all in your data centers. Now, there was still a lot of security we did there, but we were under control here. But if we go back over here, these servers can have tens of thousands of people's information here. The storage servers could have 10,000 customers' information there. What happens if this control plane's hacked? What happens if the cloud is actually hacked? What happens if somebody figures out how to get out of their environment and into another's environment? What happens when a company A who's hosted on these servers and the storage environment is accused of doing something wrong? A regulatory body comes in and confiscates the hard drives for forensic analysis, and your secret formula for a new multi-billion-dollar drug is there, or the new GPU, or the no AI-enabled robot, and now other people can see it before you can produce it to market. So that brings us to a real environment where we can no longer assume anything is safe. In the cloud, nothing is safe. Cloud providers hack, we're in trouble. Somebody gets access to some of our keys, we're in trouble. So that makes us be in a different position. So instead of trusting the people that are in my house, because they already had to go through several steps to get in my house in the first place, this is an environment zero trust where we don't trust anything. And we verify everything because we assume in an environment like a cloud where people are trying to hack it all day, every day, we assume that we're compromised. And honestly, we should be doing the same stuff in our data centers anyway, but working on that assumption. Now, we deal with today's modern cloud environments, and we've got a private cloud, 2 public cloud, stuff sitting in co-location facilities. You've got 1,000 remote locations and then wide area networks. So stuff gets complicated pretty quickly. And it's not that hard to go from one hop to another hop if you've got good things. So that's going to bring us into zero trust. And when there's zero trust, there's really about 5 things we're going to be working with. And we're going to spend some time on each one. So of the 5 things we're going to be working with, if we start thinking about the pillars that are going into what we're using, we're going to be focusing on protecting these things. We're going to focus on identity. And I'll tell you what, identity, which we'll make very clear, making sure you are who you are supposed to be, and making sure you're only doing what you're allowed to do. We're going to be focusing on devices. Here's why. Somebody hacks into your cell phone, you bring it into the corporate office, you get attached to the Wi-Fi network there, and all of a sudden your device caused a hacking event. So we're going to be focused on devices. Now, at least half of the security that we possibly have access to can be done on the network. And guess what? In many cases, what we do on the network security-wise is free. It costs nothing in terms of actual purchasing. Now, it does cost human resources, but almost nothing from a capital expenditure perspective. We will be focused on securing the applications. Because the applications the business needs to use, access the applications, get the wrong information from applications, you can steal critical data. And then that last thing is what we're going to be focusing on for the most part with Zero Trust, is how do we secure the data? Now, to be fair, when I talk about this as a Zero Trust security architecture, when I train a security architect, for example, in our architecture programs, or a cloud architect or an enterprise architect, we're talking of a good 1,000 hours of training. Now, here we are going to do it in like 3 hours, our entire discussion. So please understand it. There's only so much depth we can go here, but I think it should still be helpful for most people anyway. So working on that assumption, working on the never trust, always verify, we've got some things that we need to do. So let's first start with identity. So identity is who are you and what are you allowed to do? So that is it changes things. So in the other environment, if we go back to the old environment, realistically speaking, going back to this highly secure data center environment, here's my border. Here's my segment. Nothing can get in. All my web stuff's out here. And what I'd probably do inside of my normal data center anyway is I would have access lists determining, who and what can actually talk to what subnet and not allow routing in between subnets. But that's my data center. We've got other risk vectors that we need to know about. So in the cloud, where we have to assume identity becomes our new boundary. Identity. So that's the new perimeter, because that's the only thing we can do. We don't have a hard perimeter in a cloud provider's environment that we can use. Now, given that I can't make it that, let's say, Anastasia and Anthony couldn't talk to each other, I can make that happen via the network. But now, since I don't have access to that, realistically speaking, in most places, I need something different. So that means every time a user wants to request something, I'm going to check if that request is good. Every single time. I have an application that wants to request another application. Should that application be requesting that application? If it shouldn't be, don't allow it. This is everything. A machine's coming on. Is it the right machine? Let's say Cindy decides that she's going to plug her computer into the network. Well, is it Cindy's MAC address, for example? Meaning the Ethernet card? Or let's say she's not plugged in locally, and we're now using identity to do this. If Cindy plugs in, is she coming from a Mac like she usually does? Okay, that's a good sign. Is her Mac patched with the latest security updates that is required to enter the system? Or is it someone pretending to be Cindy? Call it Caddy. And Caddy's pretending to be Cindy, and with the computer is wrong, deny. So that's going to bring us into a very strong identity need. So that gets us outside the realm of usernames and passwords, and it gets us in to have some flavor of a multi-factor authentication. I think it's multi-factor authentication. I hate all this jargon. Multi-factor authentication means more than one kind. Many of you are very familiar with something we have and something we know. That is two kinds of verification. You go to the bank, you bring in your ATM card. That is something you have. You put in a PIN, which is something you know, and magically money comes out. It's kind of cool. So that is, something you have, something you know. Something you have is an iris scan. It's a fingerprint. Something you know is something that you could create. Multi-factor authentication uses more than them. Now, when we start thinking multi-factor authentication, not all things are created equal. One thing could be you have a cell phone, you have a cell phone number, right? So you log in and it sends a text message to your phone. Well, if anybody copied your SIM, cloned your phone, or has access to it, or your iCloud phone text message account, well, guess what? They now can be you. So that is not a strong form of phishing resistant. Your fingerprint is. Pretty hard to get your fingerprint from you, realistically speaking. A token is. We typically call these FIDO2. Now let's also think about this concept of identity. And I'll write down some of what we talked about and put it together, things for you to think of. Is it always right to allow a person to log in? Okay, let's have some fun with this one. Because in a zero trust architecture, we need to start thinking about this. Remember, we don't trust anything. So here's conditional access. We have Cindy over here. And Cindy wants to access, let's say, the shrimp ordering application. Cindy happens to be a cat. She just sits on my lap most of the time when I make these videos. So we have Cindy, and she likes to order shrimp because she likes shrimp every day, which is very true. So Cindy is only allowed access to my credit card to order shrimp between the hours of 9 a.m. to 3 p.m. We have to control her spending between those hours of the only time that she's allowed to actually buy shrimp. So conditional access is Cindy decides that she's going to try to buy shrimp at 5 o'clock and it's blocked. Now conditional access could also be this. Cindy is ordering shrimp outside of hours, but maybe there's a reason Cindy's ordering shrimp after hours. So maybe we've got this. And we say that, Cindy normally shouldn't be, so it's outside of her behavior, but what if she had to? So we can send Cindy a challenge to make sure that is actually Cindy, because Cindy generally follows the rules. And if she proves that she's still Cindy, then we allow her to order the shrimp if we wanted to. That's conditional access. Now, in the identity world, not everybody is created equal. So we have this one user. This user has the ability to create users and permissions. This one also has the ability to start and stop to launch virtual machines. This one also can do backups. Somebody said that, sent that permission for the IAM engineer. Okay. Now, this is a privileged account. And the reason it's a privileged account is this user can create a user or determine what anybody is allowed or not allowed. So we have to be very careful making sure who has these privileges, making sure we get rid of them when they don't as well. So that's typically called privileged account management. And if we're going to have in any single environment, we have to have this type of an environment. We've got something that, and I'll walk through them again. Maybe I'll write it down for the visual folks that are out here. We have to have a very strong type of authentication. Why? Because we need to be sure that you are who you claim to be, not the competitor trying to get data, not a hacker. Now, in order to do that, we need something like MFA, ideally phishing resistant MFA. I showed you what I meant by that. Something that can't be faked. And we want something from this authentication that's conditional. We don't want a security guard, for example, that only knows how to do one thing, or an IAM system like that. We want that IAM system to be able to look and say, this feels risky. Because this is risky, either don't alert someone, double check them, or something to that effect. Now, the other thing that we need to realize is we're going to typically be federated. And why is that? Because most cloud providers don't offer context-aware IAM systems like this. And it also wouldn't probably make sense for many enterprises that are on 2 or more clouds to try to configure the IAM systems and have a separate set of IAM systems in AWS, a separate set in Azure, a separate set in their VMware data center. What makes sense is for them to have one IAM system and have all those other environments federate into it. And not only by doing that, they can use more advanced authentication techniques. For example, Okta is a vendor that enables this kind of context aware. So we're generally dealing with federated environments here. And I mentioned the principle of least privilege here, but I want to make sure that we get through it one more time. So we determine the ways to make sure the user is. We determine all the ways to check out what their things are supposed to be. Let's really get into that principle of least privilege one more time. Users should not be able to do anything more than they need to do to be able to do their job. Nothing more. Because anything more could be used against you. So a really good IAM system would do something like this. We might have a user. We have a power user over here. We've got Cindy. She has chief feline officer permissions, and she's got all kinds of access to whatever she wants. Now, at the same time, we've got my neighbor's dog here. So what's that dog's name? We'll call it Rufus right now. I can't remember. So Cindy wants access to a system. And Cindy goes to access a financial system, and she's given access. Rufus tries to access the system and is denied. But we feel bad for Rufus because Rufus comes to the house a lot of time. So we do keep a little bit of dog food for the dog that needs to be there. So Rufus has access when he tries to access the dog food, and he's allowed. but Rufus is not allowed to access the financial systems. Now, Cindy, the chief feline officer, she's able to allow the system. So that's principle of least privilege. Okay, so the devices themselves. Anybody think that their devices are incredibly secure? I'm going to ask everyone this question, and I'd like you to provide your answer in the chat box. What is it that enables you on your Windows 11 computer, or for the most part, your Mac, to be able to install anything for the most part, anytime with a click of a button? What is it that enables that to happen? If anybody understands, pop that answer in the chat box. If not, I'm going to tell you in a minute. But I want you to think about the architecture, the trade-offs, because it's all about trade-offs. So here's what I want you to think about. Your Windows system, your Mac, is designed for your convenience. For your convenience means you can install anything at the touch of a button. That means the system has a lot of flexibility in what it allows to do. That generally means certain things are already turned on for you that enable you to do these things. And it generally means there's additional packages or additional software, additional stuff on your system that you don't have to install later. So that's generally why when you get an off-the-shelf Windows computer, it's not really secure. When you get an off-the-shelf Mac, it's not really secure. And guess what? If you set up your own Linux system and you install it with all the excess stuff and make it real easy to use, you're still going to be in that situation, but it's nowhere quite as bad. Because Linux tends to have less packages installed by default because it's not designed as much for convenience. It's designed more for something else. And every tool has its traits. So because of that, you have to assume that for the most part, all these devices are insecure. That's the reason these systems are insecure by the start. You can set up good authentication on them. That's not the problem. They are designed for convenience. So if we have a web server, we have to harden that server. Things like removing unnecessary packages, setting up a host-based firewall, for example, adding some extra software called EDR or more that we're going to talk about soon. Really lock it down. So we're talking zero trust, we're talking devices. So we work on the assumption that a device can't be trusted. So that means when you go and plug something in, it's not naturally just going to work. So I want you to think about it. What happens if a user has a compromised device? Give you an example. I'll show you something that we don't see too often. It was called split tunneling. Here's the way split tunneling would work. We had the company. This could be the cloud or the data center, whatever. We had a user over. We had a user attached to a VPN. This was their VPN, and then we had the user's PC. We don't do a lot of this anymore. It did have its architectural trade-offs, and I'll show you what they are. So in a split tunnel, what we actually did. It'll be easier to see if I do it this way. In a split tunnel, what we do is we create an IPsec tunnel through the internet, usually through a VPN concentrator between your PC, the cloud provider, the data center, what have you. That's your tunnel. And in a split tunnel, so that's your corporate traffic. I'm just going to put private. So that's your private. And then over here in that same split tunnel environment, they route the other traffic through the internet, publicly through the internet. Now, in this architectural model, here's what you get. You get a user over here that gets very good internet performance because they're going straight out their internet connection to the internet. And then they get a decent tunnel performance going to the data center. Now, the performance here for the user is going to be better on internet. But where's the problem? Everyone tell me where the problem is in the chat box. Tell me what the problem is of having a PC that's directly attached to the internet and the corporate data center at the same time, which is why security conscious organizations don't do this. That's why we're talking about devices. Well, hopefully I get some responses in there, but here's what I want you to see. If the PC is connected to the internet, the PC is completely hackable from the internet. And if that PC is hacked and can be hackable from the internet, that hacker can go straight through your tunnel into the data center. Everybody see how ugly this is? Yuck. Now, I'll show you why we did it. The people that designed this early weren't stupid. Here's why people did these tunnels in the past. So in a full tunnel, which is what everybody's come to, here's what happens. The user PC is connected via a VPN to the data center, the cloud provider, what have you. All the user's traffic now heads through this tunnel. Now, you've got 50,000 employees connecting via VPN. 50,000 employees are connecting via the internet to the tunnel and then sending all of their internet traffic through this thing, which means these internet connections have to be huge. Huge. Which means these network connections get a lot more expensive. And the performance would be for it also is different, and here's why. Let's say your PC users in West Palm Beach or Palm Beach Gardens, where I was living. Let's say the data center that I was connecting back to was in Research Triangle Park, North Carolina. The latency of going out Palm Beach is a whole lot less than bringing my internet traffic out Raleigh through a bunch of router hops and firewalls. So that's why people did it. And the key with architecture is there's no good or bad choices. It's only choosing the right one after trade-off. So I hope this, when we go back to it, makes sense. All that traffic was protected here. Take that back to zero trust. The devices themselves and zero trust, we assume, cannot be trusted. So if we assume the devices can't be trusted, well, we need to make sure our systems, which includes many of our identity systems and many of the other things we set up, work on the assumption that the device cannot be trusted. So if a user is authenticated, for example, the device could still be compromised. So there's other things that we might be doing to kind of protect this and make it better. So any kind of security system we have realistically should do the following. It should check and verify the health of anything before it's allowed on the system. I don't want you to think this is new. I really don't. There used to be something called 802.1x that still existed, and we could make sure in a building that the user, if a user tried to plug their computer in, we would look at the MAC address of their Ethernet card and say, yes, it's allowed in, or no, it's not. But we're getting better each day and as we get with more capabilities. So that's what we're talking about. So what do we do on the endpoints of the device? We have to make sure those endpoints are good, right? Can't let that compromised PC, that compromised router, that compromised switch be there. Well, let's have some fun with it. So we've got a lot of devices, right? Let's say here's a device over here. We've got a device over here. We've got a device over here. We can have a policy engine. And the policy engine can make sure that device has to have a certain operating systems patch, a certain kind of software before it's even allowed on the system. And what else are we going to do on these devices themselves? First, we're going to lock them down. We're going to harden. And I talked about, that kind of things themselves. And then we're typically going to put some kind of what's called EDR platform on, and I'll talk about that. We could be using an EDR or an XDR system, but let's just say we're using an EDR system for over here. And this system itself is going to be literally on these devices, and it's going to say, oh, is that device behaving normally? If so, allow. Is that device behaving in a manner that doesn't work? Well, maybe we need to lock that user off or something like that. And these systems will be constantly monitoring your servers, your users. They're going to be looking for any kind of changes to files that feel suspicious. They're going to be looking at networking connections going where they're supposed to be. They're going to analyze that activity. And they're going to make a decision. Now, at the same time, all these systems are all sent to a location. So they're sent to actually EDR, XDR systems. They're also going to be sent to SIEM and source systems. So all this stuff that doesn't feel right is not only going to go to a system that's designed to manage this, all those logs and these things are going to be sent to our security event monitoring systems. And in many cases, we may have some AI-enabled systems that can actually respond to things that are being picked up by these EDR systems. And they're going to give us good real-time threat detection so we can see what's going on, really good alerts. And in a lot of cases, we're going to have automated containment options. So maybe it'll isolate a compromised endpoint, remove it from the network or something like that, or terminate a process. So these kind of EDR tools, endpoint detection and response, they're going to give us some forensic visibility into the attacks that could be going on, trace attacker activity, what have you, and prevent similar things. Okay, while we're on devices, right? Operating systems patch. We may verify that the system meets minimum security requirements to come on our systems. We can do that. What do you think is really hard to do this with? Things like IoT devices in general. Many of them are very hard to patch industrial systems. Not all, but some. Keep that in the back of your mind. Now, when it comes to devices, we will need mobile device management. Anybody that's familiar with mobile device management, pop it in the chat box. Give me a hashtag mobile device management. If not, I'll talk about it in a second. In the meantime, while I wait, I will draw a couple of mobile devices. Okay, well, some of you, that's okay. The rest of you will by the time we are done today. So let me go to mobile device management. So I want you to think about this. You've got a company that's, say, got 80 to 100,000 employees. And most of us architects work in big companies, so we're used to this kind of environment. As security architects or enterprise architects or any multi-cloud architects. So we have this environment and we've got 50,000 laptops. We have, let's say, 50,000 phones. And we have 25,000 tablets. Let's say 22,000 tablets. We've got more than that. But all this stuff is running around. The phone person went to Starbucks. The other person went to the gym. Another person's in the sporting goods store. This person's in the shoe store, puts their phone down while they're in the shoe store, and somebody steals it. This person is at a Starbucks. They have their notebook on a desk. They go up and get a refill of their coffee. It could be any company. It doesn't have to be a Starbucks. You give your tablet to your kids while you're driving the car and they're in the back seat. You're trying to entertain them, and somehow they click a link and they install something. None of this stuff is good, right? So you've got these things floating around there. So we need to do a couple of things from a zero trust perspective. First, we want to make sure that we don't have any of these devices, let's say a laptop, they're not patched. We talked a little bit about that. What about if we notice that a phone's been jailbroken? And by jailbroken, we're referring to that we've removed all the safeguards that are there. Do you want to allow that on our system? No way. The kids accidentally clicked on their daddy's tablet, and in the process of doing that, they installed some kind of malware. We don't want that either. Now, Mike was visiting relatives in Greece. When I got to Athens, I had my phone. Somehow between Athens and Epidemos, I lost my phone. This is not a good situation. So when we deal with these mobile device management systems, we can do a few things. One is we can put what's called a digital certificate on any of these devices so we can verify they are the right device. The other thing we can do here is we can say the phone is lost, remote wipe everything on that phone with mobile device management. The other thing is we can say you can't put that application on this computer because it is not deemed a safe application. So that's what we're talking about, the device sizes. Remember when I said what we were going to talk about from a zero trust perspective, we were really going to hit these 5 key points. We were going to hit identity, which we've talked about. Then we were going to go to devices. Okay, now next we're getting to my favorite, the network. Love networking. I mean, I absolutely just love networking. Been in networking forever. I'm one of the first CCIAs that were out there. My number is 7417. It was a 2-day test in those days. So love talking about networking, but why practically do I love talking about networking when it comes to security? Because so much of it is free. I've got a bunch of routers and switches, and I can segment via VLAN. I have access control lists, determine who can get on the network, determine what traffic is more important than other traffic, determine what traffic I should get off the network in the first place. Most of these things are free. You buy the routers, the switches, they have these functions just natively there. So it costs nothing to turn them on other than proper planning. So let's talk about the network. Now, we go back to this very hardcore, very secure environment I showed you of the traditional environment. Nothing's getting in. Now we're on the cloud and everything's internet connected for the most part. In here, this network was trusted. None of this can be trusted because we've got access to the internet. None of this can be trusted anymore. So we now have to assume that the entire network has been compromised at all times. Compromised at all times. Think about the implications of everything. Now I'm going to talk about and what we're going to do next, but think about your traffic on that network. If it's compromised, better encrypt it. Otherwise, it's a problem. We better make sure that the routers that are talking to each other are the routers they're supposed to be. It goes back to that identity thing. So the network is going to be at the heart of everything. So what can we do here? Well, I'll show you the difference in a private cloud versus a public cloud. Because any kind of cloud security architect works on both. In any environment, I'm going to start with what we can do in, and we can do all that I'm going to describe right now in a public cloud provider. So one thing that I can do is microsegment. Now, in a switch, inside of my data, so I'm going to start with this. I have a switch that's got 100 ports on it. I can say that ports 1 to 33 can talk to each other and no one else. Then I can say 34 to 66 can talk to each other, but nobody else. And then I can say ports 67 to 100 can talk to each other. Now, if I don't enable any routing between them, they're all on different subnets. They're all on different VLANs. They can't talk to each other no matter what. Now, that doesn't preclude me from having access lists and other things, but just by itself, they can't talk to each other. Now, I could put a MAC address access list too that says these MAC addresses can't talk to these MAC addresses if I wanted to. I can get really granular, and it's all free for the most part. So that's in my data center. But we can still get pretty cool in the cloud. So let's look at the equivalent of it. That's not what I meant to do. In the cloud, let's look at the equivalent. So I could have a finance VPC. And I could have an HR VPC. I can have a sales VPC. And if I need to, and let's say this is the headquarters VPC, I can do two things. If I stick with the rules of non-transitive routing like I naturally get, I can make it that finance can talk to the headquarters, and HR can talk to headquarters, and sales can talk to headquarters. But if I use non-transitive routing where I don't share routing, for example, as if we didn't use, then realistically speaking, then finance will be able to reach headquarters, but not HR, and sales will be able to reach headquarters, but not HR. So, that's one way we can do it with just standard route segmentation. Now, if we were to put on a transit gateway and enable BGP to do it differently, we could make it that they could all talk to each other, but we can segment that way. Now, that's not the only way we can segment. We can segment like this. We can segment, let's say we had an environment where this was, let's say this is an extranet environment. This is where we connect to supply chain partners. And what we have here is we've got some firewalls over here that act as VPN concentrators to take incoming connections. So we can segment what's allowed in with a firewall, which is something that we would do. Typically, we use firewalls when connecting to an external network or inside. You could, even if you had a VPC, for example, or a VNet or whatever have you, you would have something that would look like this. You would have something that connects to your internet. It would be like your internet route or internet gateway, whatever you call it. It all depends on the cloud provider. You would typically have two firewalls over here. And then behind your firewall, you would have a web server. And that might be all you would have in this VNet, VPC or VNet. Maybe you had to put an app server there. So maybe you put an app server here too. But if you do, what you're going to do is you're going to try to actually create some firewall rules. You'll create firewall rules on the way that won't allow other traffic other than for the web server, the app server, for example. You'll have access control lists that protect one set of subnet traffic from another. You're going to segment that by access list. Okay. When it comes to networking, we're going to talk encrypted communications. Encryption gives us three things. And all three matter when it comes to network security. In any environment, if I'm going to share information, here's what I need to know. If I call my wife Lisa, I want to know that it's Lisa that I'm talking to on the phone, not someone pretending to be Lisa. I want to make sure that whatever Lisa said to me, that message has not been changed along the way. And I also want to make sure nobody can see the message. So this brings us into the world of encryption on a router. And I'll show you why we do it. And I'll show you where we're going to get it. But remember, we assume we're always breached. If we're always breached, that means you can access all the information on every storage, which means we need encryption. Anything like this, where traffic's flowing on the network, we need encryption. So let's talk about that. And this is what we're trying to prevent with encryption. So let's say over here, we have Evagulos. Now, Evagulos wants to speak with Christos. And they want to have a conversation. Now, as it turns out, there's this guy, Yanni. And Yanni wants to listen in on this conversation. And not only does Yanni want to listen into this conversation, Yanni wants to pretend he's Christos. So, because his goal is to collect all the information that Evagulos was going to say to Christos. So they connect that connection. And potentially, Yanni will even pass that information over to Christos so that Christos doesn't know that he's not talking with Evagulos. This is what's called the man-in-the-middle attack. So what we want to do is, by using authentications, we're doing two things. One is, prior to anything occurring, we're making sure that when Evagulos speaks to Christos, that they are who they claim to be. That's your authentication piece, which comes out of encryption as well. Now, here is the next thing. Evagulos is the CEO of a multi-billion-dollar pharmaceutical company and has a new drug that they think will be regrowing hair for people that have had hair loss. They believe this is an $8 billion a year drug. So there's a lot of information that want that. So the next thing that we get out of encryption is, unless you have the key, only Christos and Evagulos will be able to understand the conversation they had with each other. So it's like gibberish to everybody else. Now, the third thing is absolutely essential that we get out of encryption, and it's integrity verification. So that means when Evagulos sends that secret formula to Christos to have that thing built, we don't want that secret formula being changed along the way, so we can prove that it hasn't been compromised. To imagine it a little differently, imagine Evagulos is a physician and Christos is a nurse. And Evangelos prescribes 4 milligrams of a medication, and the hacker already changed it to 400. And by the time it was given, the patient died. So that's that message integrity. So what ultimately happens in encryption is we hash the message and we can make sure that it doesn't change. The last thing I'm getting out of encryption here is something called non-repudiation, which means that after Evangelos sent that message to Christos, he can't say that he didn't send it in the first place. So in anything involving the network, guess what? We are now in a position to know what's going on. Now, let's talk about route filtering. Again, I love this because it is completely free. So we've got this subnet. We've got another subnet. And we have a third subnet. Subnet A. Subnet B. Subnet C. Let's say they're all connected to this router. This router is connected to this router. R1, R2. And these can be virtual routers in the cloud, physical routers outside the cloud. It really doesn't matter. It's the same. And the router on this routing table has a route that says, I'll draw a routing table, and it says subnet A. And we'll call this interface E1 or GE1. So this router will have a map on it that says to reach subnet A, use GE1. It might also have to get to, oops, let me make this a little bigger, in its table, subnet C, GE1. So in this particular case, this router, oops, I'm going to say GE3. This router over here knows how to reach this subnet and this subnet, but not this subnet. So now we have a user over here that's connected to this router. They forward their packet to this router because they want to try to reach subnet B. The router doesn't have a route to the packet and it just drops it. So by not providing information, routing information, things become unreachable. Have you ever wondered why we use BGP for internet routing? Because it enables us to say we're taking in these routes, we're giving you these routes and nothing else, specifically for that thing. So BGP is going to give us a lot here. I talked about non-transit routing. Now, the host itself. Should I allow traffic into that host? I got a server. The server is a web server. It only supports HTTPS. Tell me what traffic should be allowed in that chat box to that server that only supports HTTPS. And not only will we restrict that with other things, but we're even going to we're talking about the host itself. So the only thing that should ever be allowed into that server is TCP port 3 traffic. Everything else should be blocked. Now that means if we have IP tables running on a Linux machine or UFW and an Ubuntu thing, it should filter it out there. It also means if we've got an AWS security group, we should be filtering it out there. It means if we've got a web application firewall, we filter it out there. And it means if we have 2 next generation firewalls in front of that, we filter it out there. So in the end, it's going to be many layers of security because we assume that we're going to be compromised. We assume that we're hacked. So that's why we're doing these things. Okay, we had some fun on the network. Let's talk about applications. So applications, are they going to be the things that we're actually using? The applications in so many cases become an attack vector. We don't want that, right? We don't want to be hacked via the applications, do we? I know I don't. So given that type of a situation, we are going to have to, as part of our zero trust framework, get involved of applications. Now, if you've just joined us, you can obviously go back to the beginning and watch now and go back later. But, we've talked about identity, and we talked about devices, and we talked about networking. Let's talk on the application side. Now, those applications are going to be the interface between a user and the user's data. So the application itself is, wow, this is a gold mine to hack for the hacker. So we in the zero trust philosophy really want to make sure that we know that you are who you are before you even touch the application. So we're bringing back identity here, identity on the networking, identity on the remote access, identity on a server attaching to each other. So we're going to start that. But what else? So if we think about applications, and maybe I'll just I'll draw some down and whiteboard along the way. There's going to be a lot of things that actually has to happen. So if we design our applications and then think about security later, that's the equivalent of taking someone, feeding them all the worst food for their entire life, and when they're sick, saying, now we can put you on a diet, an exercise routine, and a medication routine, waiting for them to get sick. I don't really believe in that. We want to prevent this stuff. So when the software is designed itself, we want that to be done very securely. So if we start thinking about software and software security, we have to think about a lot of things. The developers that are writing this code, where is it coming from? Don't believe that thing that developer found on some public GitHub page is going to be good or secure in any way, shape, or form. And don't assume your Claude-driven code is going to be secure either by itself, or ChatGPT code or Gemini code or any other system that really does a relatively good job. Nothing is going to come out that way if we're not careful from security. So first, we have to think about where the code is coming from. And then that code is going to have to be tested by some engineers. Now, when we think about this, organizations that are using modern DevOps pipeline are going to integrate code testing as part of their CI/CD pipelines. They're going to be searching for vulnerabilities in that along the way. Test it, go back and forth. You'd be surprised at what you think about. So that's one part that we need to think about from the secure applications. All right. The next thing is, what should you be able to do when you interact with the system as a user? Have you ever noticed when you try to put your email in, if you try to put something that doesn't look like an email, it won't let you on most systems? Well, there's a reason for that. If you take a window on a web server and start injecting malicious content, if the server is not trained not to do that, for example, you could be releasing all kinds of things, force that server to crash. So in good application design, we do something called input validation. And I'll show you what I mean by that. We'll pop this in here. So we've got a field for user input. We don't let that user, say we've got a user, we don't let them put down information into this that's not right in the first place. In network, we don't allow routes that we don't need or don't want. We don't allow users to enter anything that could be damaging to the system. Why would you? So that's called input validation. Now, we probably will also do something called output validation with regards to these systems, and I'll explain to you what I mean by that. So if we determine what can come into the system, we also have to be very careful what can come out of the system. We don't want to add any kind of weird user-generated content that comes out that gets displayed that could generate a cross-site scripting attack or something like that. So input validation tends to present SQL injection, output validation, typically cross-site scripting attacks. Now, I know I talked a little bit about where this code is coming from, but that is a serious issue. Third-party libraries, open source communities. You're going to find a lot of vulnerabilities in this stuff. Any kind of automated tool should be constantly checking for vulnerabilities, constantly checking for security fixes. And at the same time, we probably, for our organizations, need to come up with trusted repositories of things that are trusted. And that way, you know, it's a golden path for developers to use it. Security testing. Okay, so we've got the applications themselves. We need to constantly test these things. So the applications themselves need to have fairly frequent security assessments, meaning they'll be scanned for various vulnerabilities or weaknesses to the system. We will use penetration testers periodically. We will pay them to break into the systems to find weaknesses in our systems. And we're going to need all that. You know, we can use automated tools early in development, but ultimately we need serious regular testing to make sure that things are there, including potentially breaking into the system. Okay. So that's one thing we're talking about. Now, one of the things that I want you to think of is it's very hard to secure things that you don't own. And in cloud computing, they call it the shared responsibility model, where you're responsible for their stuff and they're responsible for their stuff, like the infrastructure or whatever. But it's hard to guarantee that other people are there. Now, let's start talking about software as a service applications, which are common in cloud computing, say Microsoft Office 365, Google Docs, Google Office. You know, these are commonly used applications. And they're great. But what control do you have over security in these types of environments? IAM, and that's it. Because the underlying infrastructure, their storage, their switches, their firewalls, all that is maintained by them. You've got no control. Now, the trade-off of the no control is you've got lots of convenience and it's super easy to use. It's the easy button, so you're gaining something too. And in many cases, they might be better at security than others. So I'm not saying good, bad, or anywhere in between, but we don't necessarily have control of these remote environments. So that make us need to do other things. So we're typically going to get involved in cloud access security brokers and other things. So I'll show you what we would typically do in some form of a good, strong application authentication environment. And this could be Microsoft Entra ID, Okta, Auth0, any kind of commercial environment. So let's say we have a user. And this is very common. So we've got a user over here. And the user wants to access the SaaS provider over the internet. And what happens is, as soon as the user goes to connect to the SaaS provider, maybe DNS gives them a redirect that gets them to, say, an identity provider like a cloud access security broker. So I'm just going to call it an identity provider. So the user means to go here, but the user gets redirected to the identity provider. Now the user enters their username and password to the identity provider. And then the identity provider reaches back out to that user and offers, say, an MFA challenge. The user uses their, let's say their authenticator app. And they send back and they get a Java web token. And ultimately, after they get that Java web token, they use that web token to access the SaaS provider. So this is very common where, we're going back and forth with these phishing resistant authentications. And why are we doing it? Because when I stick my identity provider here, I can make sure, like I can set up a policy that says you can't pull data out of the SaaS provider. I can't do that with just the SaaS provider. I can set up that kind of policy. I can also, by setting up an identity provider, I can force you to use an encrypted tunnel along the way, even if you didn't. So we're using identity providers in many ways to enhance the authentication, but also enhance our control over uncontrollable environments. So we talked about a lot of things in the application so far. So what about an application level authorization check? So we've already talked about limiting what you're allowed to do, what you're allowed to put in it. But what happens when the application itself tries to do something it's not supposed to? Okay, well, if we think about that, if any of you have kids and the kids do something they're not supposed to, you try to stop them. I have a cat named Cindy. She loves to try to catch animals out there, and I try to stop her because I just don't like to see it. I feed her plenty of food. She doesn't need to do that. So we're now at the application level going to issue some kind of application level authorization check. So we'll go back to the things we're doing over here. We'll try to add a little more content to this. Oops. So we already were in this environment where we determined we wouldn't let the user put stuff in. But what happens when the user finds some way to ask that application to do something it's not supposed to do? Or an application tries to do something it's not behaved to do. Inside of these applications, they should have a means to kind of stop this as well. And that's going to be absolutely, absolutely critical. All right, we're going to get into securing APIs, but let me just see if anybody has any questions on what we've covered so far before we go to the next thing. While I wait, I'm letting everyone know tomorrow we have an architecture webinar where we're going to talk about how to become a security architect. We'll talk about the skills that you actually need. For example, we'll talk about what we do, what we don't do, what hiring managers are looking for example. And it's free. You can sign up for that free webinar. The link is in the description, as well as my team just dropped it in the chat box. Give me a hashtag security architecture if you're here or if you're awake. I love security architecture. I hope you do. And maybe give us a like. Maybe share this with others to help them develop their security architect career or any of their security careers. Then I know you're awake. I see Anthony's over there and awake. I really appreciate that, Anthony. I know you're there. All right. Well, don't seem like we have a lot of questions, which is interesting to me, but okay. So hopefully we're getting everything along the way. So let's talk about securing API gateways, because that's also part of the application as well. So we might have something that looks like this. And if a question was asked, we'll get to it at the next one, the next break, since it came in after we started. But so let's work in this particular environment. Let's look at a typical the way and some APIs might be set up in an application. So let's say over here, we've got a mobile app. And the mobile app is connected to the internet. And that's connected to an API gateway. And then the API gateway goes to say, we've got 3 microservices here. We've got an account service. We've got a payment service. And we've got a transaction service. This is the way the flow should be coming in. But where people go wrong here is they forget a few things. This API gateway is now an entry into your systems. So by that, before anything should be here, we need to have some good authentication mechanisms to make sure you are who you're supposed to be. And we want to determine what your traffic should be like. And I'll explain to you this. So let's say we've got Hal the hacker over here. And Hal the hacker wants to send a tremendous amount of bad traffic to this API gateway. Should we let him? Tell me in the chat box. Should we let Hal send unlimited traffic to this API gateway? Or should we determine the amount of traffic that anybody is allowed to send and limit them to a safe amount of traffic with something called rate limiting? And we will be using rate limiting for that reason. We do this on networks. We can do it here. We can do it with firewalls, all kinds of things. Now, let's say there's a part of the world where we don't do any business whatsoever. I don't know, there's an embargo. You're not allowed to do business with this part of the world. You haven't been for decades. And if you do, there's usually something associated. So why not just block these IPs in the first place? Don't even let them be there. We block them. We IP filter. So what we really want to do is to make sure that parts of the world that can't deal with us don't have the ability to, or Hal the hacker. So all of a sudden, Hal the hacker, we rate limited Hal the hacker. We notice Hal the hacker is trying to do something. So let's just block Hal's IP address and let everybody else in. So these are the kind of things that we typically do on the API side. Now, what else do we do from an application security perspective? We want to do a few things. One is, if applications are behaving the way they're supposed to, everything's great. You know, if you're riding on your bike and you feel great, everything's great. All of a sudden you feel sick, you know, it's time to get off the bike, right? Maybe stop. Maybe call emergency services. I don't know. Maybe eat something based on whatever's wrong at the time. Well, same thing that we want to do for our applications. We're in business. They could have hundreds of them or thousands of them. So in this particular environment, we want to be able to doing some more things on the application side. So I'll talk about what those other things are for you. We typically have, oops, this is not. We have systems called RASC systems, and I'll explain to you what they are. So what we have here, in this runtime application security environment is something here that's going to be looking at those applications all the time. Are they doing what they're supposed to be doing? And they're going to be looking at these systems. They're going to be looking at the behavior of these systems, how the applications actually behave. And then if they don't like something that it sees, these systems have a lot of things. They can just log the event. They can block it. They can send an alert. So if you really start seeing these things, if you really get the picture, all of this stuff is sending logs more go to other. We've got more SIEM and source systems. We've got applications looking at the logs. It all starts to piece together. But why are we doing this? Because we want to detect things in real time. We want to identify compromised accounts. Start to see where it's piecing together. I authenticate you before you connect. The devices authenticate each other, like the routers and switches, before they're allowed to send traffic. Application connects to other application that typically uses some form of a token to prove they are who they claim to be. We've determined who can do what. We've determined who can talk to whom, so to speak, how much traffic can be sent from point A to point B. Then we talked about the applications, the design of the applications, for example, and what have you. So there is that. So there's that. Now, I'm going to mention web application firewalls here because they do fall under application security. But I want you to understand where web application firewalls are good and where web application firewalls are not good, what they're good for, what they're not good for. And I'm going to compare these with firewalls. And I'm also going to talk about different kinds of firewalls specifically. Here is what I actually mean by that. So we are going to have two, let's say this is the internet. Right underneath the internet, let's say we've got a firewall. And then we have a load balancer over here. Let's just call this our load balancer. And behind that load balancer, we typically have our web servers or an application over here. Now, what we can do is we can apply a web application firewall depending upon the kind of firewall, either to this load balancer or to these virtual machines or containers that are supporting the applications, usually a virtual machine. We could do that. Now, what is the difference between this firewall and this firewall? Because we're going to be using both. This next generation firewall has a lot of capabilities. We use that to protect everything behind it. So this thing gives us 100% ultimate control. Who's allowed in? Who's not allowed in? We're protecting the entire domain. So let's just say this is a domain. They're protected by these next generation firewalls. Now, these firewalls are so good at what they actually do, they're not going to let that much traffic through them. They shouldn't let any except for what you apply. Now, by putting a web application firewall either on the load balancer or the application server itself, that web application firewall is going to be looking for the kind of things that only happen in web applications. Your next generation firewalls may do it or may not do it, but in this particular case, the web application firewalls just protect the web application. So A web application firewall, let's say we put it over here. And I'm going to want you to understand the difference between a cloud provider's WAF and more industrial WAFs, because they are not the same. And your security implications are major difference. So the WAF will look at something like an SQL injection attack and say, I see it, I recognize it, I stop it. Now remember, the input validation we talked about from application security should have also blocked it, but we use more than one. We talked about output encoding, reducing cross-site scripting, but guess what? These web application firewalls can do it too. These web application firewalls stop command injections, for example, API abuse. So we're going to be using both. Now, here's the difference between these modern next generation firewalls that come from your security vendors versus the majority of what your cloud provider has to offer. It's a major difference. So let's say we've got two sets of firewalls. So, and these are the way these two firewalls will actually behave. So here we have a traditional firewall. It might even be very much like our cloud provider's WAF. This is a highly intelligent firewall. It operates typically at layer 7. So it's a good firewall. It is tuned for web apps and web vulnerabilities. All of this is great. Now we have, let's just say, the Palo Alto type WAF, or the kind of WAF a Cisco or a FortiGate would typically grant. So let's look at the difference, because the difference here is very big. And if we're going zero trust, we want the difference. So here we've got like your typical cloud provider firewall, and they allow whatever the appropriate traffic is to the web server, whatever is considered appropriate. And they allow it to come back. They block everything that's not appropriate as far as they know. So this is great. Now let's go to the next generation firewalls, the WAFs that your security vendors do as opposed to the average cloud provider one. Now they do the exact same thing. They allow the traffic that's destined to that server in and out. But here's where it changes. With the cloud provider, you can often buy what's called signature detection. And I'll show you what signature detection is. It's typically an add-on. So with signature detection, what happens is it's like your antivirus. Once we learn about a new kind of attack, that cloud provider's WAF combined with an additional user that has signature detection will put information on this firewall. And then this firewall will be trained to recognize patterns of attacks that have occurred before. So last week, somebody tried to attack something. The signature was updated, and now this firewall is smart enough to block something that it's seen. Okay, let's go to the next firewall, because these firewalls have behavioral detection and signature detection. They're better. So now something that's been seen before, this firewall blocks just like this one did. Okay, here's where it gets interesting, and here's where you typically speaking end up with something that's not made by the cloud provider. Now, a brand new attack occurs that no one ever heard of. So, oops, here's what happens here. Brand new attack occurs. The hackers are really smart. They break right through this firewall, and the system is now hacked. Okay. Now, the industrial grade next generation firewall type WAFs blocks all traffic that's not supposed to be there, blocks anything that it's seen before, and now a new attack comes in, and the AI in this firewall says, I think I'm being attacked right now. I don't like this. And that behavioral anomaly detection blocks an IP address, creates an ACL, resets a TCP connection, does whatever it needs to stop the attack while it's occurring. This is why, generally speaking, this is great for a certification exam. And generally speaking, industrially, that's why we typically use a more industrial security vendor. Hope that makes sense. All right. Well, we talked about a lot of elements of a zero trust architecture for security in your cloud environment. Let's go over what we talked about again. We went through a whole lot of these elements. So we talked about identity, and then I showed you how we use identity everywhere. We talked about devices, right? And we talked about, authenticating devices, protecting the devices, mobile wiping them, all these kind of things. We talked about the network. We talked about segmentation and micro segmentation and firewalls and access lists and rate limiting and route security and VPC or VNet security. Then we talked about applications and what goes into secure application development, what have you, and all this other good stuff, which takes us to data. So what I'll do is I will go through data, and then at that point, we'll open it up for questions. And let's have some fun with that as well. So now we're going to talk about data. So if we really think about data, in today's world, the data is one of the most important assets an organization has. Companies want to do AI. Their AI is nothing without the quality of their data. Bad data means bad AI. Good data means we can learn from our customers, learn their buying patterns, learn what they want, what they're willing to pay, and create new products, new marketing campaigns. Bad data means our competitors crush us. So we have to understand that data is a very strategic asset. And when you have something that's worth a lot, you have to protect it. So in zero trust, we assume that we're breached at all times, all that time. So let's talk about how to protect it. And we're going to have a lot of things that we can do from a data perspective. And we're going to talk about it. So if I take my data and I encrypt it, which means I turn it into gibberish, and the only way you can take gibberish back to the data is with the decryption key, that is a very strong form of data security that we're going to be using. So encryption. So we'll play with these. We'll draw it down. These are security architecture fundamentals. So let me spend a few minutes on it. So this is what the data looks like. And after it's been encrypted, it looks like this. And you can't see it or understand it. But if you have the decryption key, you can take this, bring it back, and all of a sudden you figured out that the message was cat. I like cats if you haven't figured that out. So encryption is going to be something that we have. I like dogs. I like birds. I like anything with fur or feathers, just like animals. Okay, so next, the data itself. Is all data equally valuable? Is everything you own, answer me in the chat box, of equal value? Is your car worth the same thing as a fork inside of your kitchen versus a piece of paper that you got in the mail yesterday versus your bank account? So not all elements of data have equal value. So one thing that's going to be absolutely critical in any security architecture or cloud security architecture is to categorize and classify our data. This is top secret. It can't get out. Okay. Well, then we need to protect that data like something else. This data, if it get out, nothing's going to happen. I mean, for example, how much security do you think I would put around photos of my cat, Cindy? Not a lot. She's a cat. She looks like any other tabby cat. Beautiful to me. But, if you see my cat, Cindy, you see my cat, Cindy. I'd probably show you a picture of her anyway. But there's other things that would be sensitive. So let's go back to this so we can keep it here. So we have to classify. as we classify, we're now in a position to determine what we can do to protect it. Now, let's think about monitoring access to this. I have data, right? Would it make sense to see who's accessing it? Would there be a good reason to make sense who's accessing it? Of course there would be. So we need to access who's monitoring the systems. Okay, now data loss prevention. I have the secret formula for a new drug that can cure cancer. All right. That is a highly valuable asset, right? Worth billions, trillions of dollars. Now, there might be other companies that want to kill it because maybe they're making a lot of money in their drugs, for example. I'm not saying there would be or there wouldn't be, but there could be. There are also a lot of people that would try to steal that formula to sell it for themselves and make the $1 trillion off of it. So we need to think about data and keeping data. We can't afford to lose data. So I talked earlier about categorizing our data and classifying our data so we know what matters. Now, if I mark data and say sensitive versus non-sensitive, wouldn't it be cool if I could use technology to say sensitive data is not allowed to leave the system? Well, I can. So let me bring you into the world of data loss prevention, and I can show you how these things work. And I'm gonna give you the beginning ways people used to do this. And let's say this was the user. Let's say this was a PC. This is what people used to do. And I wanted to make sure you couldn't stick a USB drive in your PC. This was the old days before we had a lot. What do you think we did to these USB drives? We broke them and then unplugged them for the motherboard too, but we broke them with a screwdriver. That was old school data loss prevention. Now what do? Realistically speaking, we use software. It could be on the device itself that makes it impossible for you to copy or remove information. And you know what we still do in a really high security environments? We still break the USB ports and things like that. But that was what we could do. And that's still one thing that does go on in high sensitivity environments. But what we can also do, for example, let's say this is our internet. We can put in what's called an egress monitoring data loss prevention system, and I'll show you what I mean by egress versus ingress. Let's call it private stuff. So ingress traffic is coming into our systems. Egress traffic is leaving our systems or exiting our system. So what we do with regards to egress monitoring is all of a sudden somebody tries to email some data and the egress monitoring says, nope, you can't send it. So that's another place where we do data loss prevention. So that's going to be part of our data protection strategy. Okay, so here's something I want everybody to think about. In business, let's say your customer data might be useful to you for the next 12 months. After 12 months, that data is completely worthless to you. In that environment, how long should you keep your data unless there's regulations? Everybody tell me in the chat box. It's useful for 12 months. There's no validity after 12 months. And and there's no regulatory reason for you to keep it longer than 12 months. How long should you keep it? Let me know your answer in the chat box. And then I'm going to talk about the repercussions to keeping it. Okay. I kept a tremendous amount of worthless data that provides no meaningful benefit to me whatsoever. And now a hacker catches it. A hacker gets in, and they get access to data that is worthless to me, that I paid extra money to store, and it's now extra information that is still going to cost me as a data breach. So we want to keep that data for 12 months or less. Exactly. We don't want to keep data. We don't want to keep things that are no longer serving us. Like the old yoga expression in a yoga class, let go of what no longer serves you. Because keeping that data around is just a way for you to be further harmed in an attack. If you really think about it, it's not a lot different than going outside. You stuff your wallet full of cash with all the cash that you have, or you take just enough with you and you keep the rest of your cash in a safe place. Cash loss prevention, data loss prevention, whatever, same kind of stuff. So with regards to our data, there are other things that we might need to do to keep our data more clean and secure along the way. For example, we can do things like tokenize the data, where we replace data with a token. We can mask data by only giving you access to a certain thing in a database. So we've got what I call the privacy techniques. Data obfuscation, tokenization, anonymization, pseudonymization, all that good stuff. All right, so I talked encryption, and I talked encryption of data. Where do you encrypt your data? Well, before I talk about the 3 kinds of data encryption that you need, I'd like you to think about this. First thing we're going to do is we're going back to our primary data center, the private cloud that the one company owns for itself. Most people encrypt their, so so we have our storage, and in our data center, all the workloads are going to go into DRAM and to CPU in our servers. Our servers. We're the only customer on that server. In the cloud provider, we may have hundreds of customers, depending upon the size of the server and the type of server on a single server. Thousands of them with shared storage and shared servers. So the CPUs, the DRAM of these servers may have 50 different customer stuff in the CPU and DRAM at the same time. Why am I showing you this? Because I'm going to show you the main place where most people are already letting their data not look overly secure. So here's what most people think of. Most people think about encrypting their data when it's stored. And this is usually in today's world AES 256, encrypted storage. Most people think encrypt in motion. And this is where we get into either like IPs, SEC, or we get into TLS type encryption. This is what most people do. Want to see something scary? Now let's go back to our cloud provider, because this is what most people do. their data as it's flowing through the network is encrypted. So we're good in this. So this is what most people do. They, in their cloud provider, they encrypt their object storage buckets, for example, their block storage hard drives. They do a good job of that. Then they encrypt their information in transit with TLS. And here's what happens. Data comes out of storage. It gets decrypted to run on the CPU. It's then in the same CPU with 50 other customers' unencrypted information, all sharing the same pool of DRAM. Anybody like that? Anybody think this is a really good idea to have your stuff de-encrypted in DRAM and the CPU, along with hundreds of other customers at the same time? Let me know if you think that's a good idea in the chat box. Okay, so what can we do? There's another type of encryption we're going to talk about, which is called homomorphic encryption. And I don't know who makes up these ridiculous terms. But here's what homomorphic encryption does. It keeps your data encrypted while it's in the DRAM or the CPU. So in confidential computing or secure computing, we want to also encrypt while it's actually being used. One type of this is homomorphic encryption. Now, this in your data center might not have been that critical. This in your cloud provider is absolutely essential. Absolutely critical and essential. So, if we talk today, and we talked about, these pillars of zero trust. And we talked about looking at things with the perspective that we're always breached, meaning we're always compromised, that we don't trust anything or anyone. It brings us back to the concept of identity, making sure we've got a good, strong means to determine before we let anything on the network that they are who they claim to be, or the system. Then not letting anything or anyone or any system do more than they're supposed to be able to do their job. Then the devices themselves, because they present an attack vector, have to be hardened. We need all the types of management we talk about, patch verification, device verification, what have you. The network itself offers us some of the biggest opportunities for free. Stick an access list on, rate limit this, prioritize the video traffic over hacker traffic. I mean, so much is there and it's free. Now we've got about 10 times more of that in the data center than the public cloud, but we can do things wherever we need. We talked about the applications, everything from input validation and sanitizing what you can do to determining what the applications can, to authorizing them to web application firewalls. And then we talked about data and securing data. So at that point, who has questions for me? Any questions for me? What about securing images of Docker applications? So if we think about securing Docker images, it's really about securing a few things. One is where are we getting containers from, that container supply chain. So we want to control where the images come from, what's going to be allowed into them, and how we validate them before them. Generally speaking with containers, and of course we're going to be using everything we talked about, the same identity, the same encryption, the same everything we talked about today. But we'll also try to make sure that we're using containers from an approved base of images, for example. We want to constantly scan these images for vulnerabilities, any kind of embedded secrets that a developer left in there, for example. We constantly want to make sure we're enforcing any kind of security policies and any CI/CD pipeline we have. And we even want to cryptographically sign these images so we can verify that those images haven't changed by a hash that we placed on them. We've got the integrity of the image. So all the things we talked about today, but also those other components of it as well. Good question. Who else has questions? You don't have to be shy. See if anyone else has them. If there's no questions, and that's okay, I'm going to go play with my cat Cindy because my wife's coming home tomorrow and I have to dedicate more time to my wife than the cat. But if there's questions, I really want to help. So while I wait to see if there's any last questions, I do want to remind you of a few things. Tomorrow, we're going to have a webinar on how to be a security architect. We actually hold 2 webinars per week on architecture careers where we talk about what we do as architects, why architecture is a unique field and the things that you actually need to do and learn, the right skills to be an architect, which are not what most people think they are, what hiring managers desire in an architect when they interview them, what kinds of things belong in your architecture portfolio, even every part of it to make sure people come to you as opposed to you not necessarily having to apply for jobs. It's all there. We talk about it all. It's live on Zoom. It's completely free. And I'll answer any questions you have. So let's see. There is that. And I also want to remind you there are other free resources in that description, free guides on your career, what have you. So looks like we have some questions that, realistically speaking, that had come in. There are tons of policies and tech involved. How does a security architect or organizations keep track of these? And what about changes breaking things? So, what most people don't realize is they don't realize what we do as security architects. They think we're like an engineer that's configuring things. When it comes to a real security architecture in an environment that I'm working on, it's me. It's potentially a team of 10 other security architects and a whole bunch of architects from other domains. So as that lead architect, I'm basically keeping track of these systems, and I have a whole bunch of people that are working with me, for me, to put this together. An organization's architecture team in many enterprises could be hundreds of people. There could be a small number of enterprise architects that are focused on, for example, the optimizing the business, new business architectures, what have you, new business strategy, roadmaps. There'll be a tremendous amount of platform architects like multi-cloud architects, AI architects, security architects, network architects doing their things. And then after that, we'll even have solutions architects helping us at that workload level. And we'll usually even bring in engineers on our team. So it's about creating the right kind of architectural repository. It's about having the right kind of messaging. It's about organizing the content in a right way, the executive communication strategy. So it's going to take a lot. And that's why this is not a job where you're going to design for 6 months and then build for a month. This is the job where it takes 6 months of questions, you and your team of 10 people. So it's not going to be something you're going to do real fast. It's going to be something where you get to know the client, speak with some stakeholders, business stakeholders, tech stakeholders. Then you start talking to employees, then you start talking. And as you start to learn more, it again becomes part of you. Kind of like your house. If you just went into somebody's house the first time, you don't know where anything is. But after you've been there for a little while, you'll be there. As long as your fundamentals are good and you know what all this stuff is and where it fits together, it's much easier to learn these. Great question. Thank you very much for the informative session. We are so grateful that you joined us, and we are so honored and that we can actually be here to help people in their security careers. Alec, it was so good to see you. Didn't expect to catch me live. You just started filling videos in the channel. No questions. You're just learning, and thanks for the free info. You're more than welcome. I'm thrilled you joined us. I'm thrilled that you were here. And I remember learning too. We all start that way. I was a medical professional and a nurse practitioner practicing internal medicine when I decided that I love tech. And I've been there for 25 years. So wonderful. Okay, well, hopefully you had a good time. Hopefully in this cloud security training, you learned a lot about designing zero trust cloud security architectures. I only had a couple hours here as opposed to the 1,000 hours I typically spend when I train an architect, but hopefully this gave you a great introduction to cloud computing and cloud security architecture fundamentals. If you had a good time, maybe give this video a like. Maybe tell a friend that desires to build a cloud architect career, or a cloud security architect career, or anything in cybersecurity about these free resources. Sign up for our mailing list. And for the people that sign up for this list in this video, my team will actually reach out to you with some free certification training we have for, say, the CCSP and the CISM and other free things to help you in your security career. Thank you all so much, and hope to see you soon in another video or another day. Take care.